Hey everybody, today I'm going to be remaking the concatenation video, the first one, and the second one. That'll be the next video. But the reason why I'm doing this is because A, there were a couple of mistakes in the videos, so I wanted to fix them, and then B, I'm going to be making some more videos on concatenation in the near future, so I just kind of wanted to update everything just to make it more, like I normally am, because I made those other videos way in the past, and that was like close to the start of my channel. So I just want to redo this just for you guys and offer a better explanation as well. So first I just want to make you guys familiar with the floor and the ceiling functions. The floor function, basically I just think of it as rounding down, ceiling is rounding up, and you can see an example here. So I have a video on this, just a short video, and yeah, so let's actually get into it. So the best way, so actually first let me talk about what concatenation is. So concatenation is pretty much if you take a number, let's say 25, and concatenate it, we use this notation with, I don't know, 3, yeah, just 3. This is equal to 253. Something like that. You just basically put those two numbers together. Super useful in computer science, where you're basically putting two strings of text together. So like hello concatenated with world would be hello world, stuff like that. And just useful in other areas. In math, it's not really so useful. This is really pretty much what you can do with it. I mean, there are some uses. That's why I'm going to be making more videos on them. But yeah, they're not super applicable, but it's just fun to play around with, kind of like geometric calculus, the product integrals and all that. So let's just begin by finding a formula, because why not? So the best way I can do this is by using an example. So, I mean, yeah, 25 and 3 is a good example, but let's use like 3 digits and 2 digits. So let's say, I don't know, 367 and 28. This is going to be 36728. That's going to be our answer. So now we just have to find a way of expressing this. Well, I mean, we can write this as 367, right, times 100 plus 28. We're basically just breaking down the numbers. So we have this number times 100 plus 28. Why is this specifically 100? Well, we can further kind of work with this and say this is 367 times 10 squared plus 28. And this is 10 squared only because this guy is 2 digits. If this had another digit at the end, we'd have a 10 cubed, right? So this number here is equal to the number of digits in this number. So now what we need is a way of finding how many digits a number has. Well, there's a really cool trick with logarithms to do this. So if we take, let me do it over here. If we take the log, actually let me talk about, so the log of base 10, I'm dealing with base 10 here. Log of 0, I'm sorry, log of 0 is undefined. Log of 1, so 1 is equal to 0. Log of 10 is equal to 1. Log of 100 is equal to 2, and so on, right? So you can keep going, right? So any number, if you choose a number, let's say x, right? So if we choose a number x, and it is between 1 and 10, and I'm going to say it, hold on, and I want to say it includes 1, but not 10. So this is any one-digit number, so any number between 1 and 9.999, I mean, it's just 10, or, any one-digit number, or anything like that. We're going to get, this is going to be equal to, the log of x is going to be between, well, 0 and 1, including 0, right? So this is really important, because what this says is that any number between 1 and 10, including 1, will give us any number between 0 and 1. But what we want is 1, right? Because this is going to be a one-digit number, so we want a 1, right? So what we can do is we can actually take the ceiling of log of x. So the ceiling of log of x is going to be equal to 1. But that is only if, so, and actually I can put this double implication here. That is only if our x is between what exactly? Well, again, it's going to be between 1 and 10, right? But does it include 1? Well, the log of 1 is 0. So no, it's not going to include that. The log of 10 is 1, and the ceiling of 1 is just 1. The reason why here is because the ceiling of 0 is 0, so it's not going to include, it's not going to be 1, it's going to be 0. So this actually includes 10. So we've run into a problem. Because here, we're saying we want to include this, but here we're not, and we're including this instead. So this is, I kind of went with this in the first video I made. I went with this, but it's not exactly that. There's one slight adjustment that we can make. So let me give you a property of the floor and ceiling functions. Let me do it over here. Do I have another color? I can use this blue here. Alright, so we can pretty easily see that the floor of n, right, so the floor of n, no, actually I want to do the ceiling of n. So the ceiling of n minus the floor of n is equal to 1. So let's say, like here we have, it'll be 2 minus 1 equals 1, right? So pretty much we can replace that with the log of x. So, and actually we can also move this to the other side. So the ceiling of log of x is equal to the floor of log of x plus 1. And so pretty much we can use this. Now you might be like, well, if they're the same expression, then what's the difference? Well, actually it does make a slight difference, and it's the difference that we want. So if we just do this, so if we just test so we'll have the floor of log of x plus 1. If we test 0, if we test 1, so log of 1 is just 0, right? Floor of that is still 0, plus 1 we get 1. That's what we want, right? If we do the log of 1, log of 10, the floor of that is just 1 still, right? Because log of 10 is 1, floor of that is 1, plus 1 is 2. And that's that, because this 10 is a 2-digit number. So that's exactly what we want. So pretty much this works. And again, same thing between 1 and 2, right? And so in this case, it's going to be like that. So our expression to figure out the number of digits that a number has is going to be in the exponent. So in general, so let me get rid of this. Let me just get rid of this here as well. So in general, A concatenated with B is going to be, well, the first number, right? It's going to be A times 10 to our digit counting function, which is precisely this. So the log, or the ceiling of log, the floor of log of x, but not x actually, it's going to be of the second number, right? Because we just want to find how many digits that has. So it's going to be b, right? Plus 1. And then of course we add the b at the end, plus b. Let me make that explicit that it's not in the exponent, so plus b, like that. And this is our concatenation formula. And I hope that makes sense. I hope this is clear from this formula, or from this example, that it is in fact that. And this isn't totally a proper proof, and it's not really supposed to be a proof because we're just kind of defining what the concatenation formula is based on what we want it to be. So this is kind of the best we can do. We can't really, I don't think there is a really a way to formally prove this. We kind of just do it through an example, and it's pretty easy to see. Okay, so in the next video, we're going to actually extend this, so it's not just between two inputs, but between as many as we want. Why, you may ask? Because why not?